Oh my gosh, this page is sideways. What's going on? Madness, chaos. Okay, remember we had this. This took some time, right? Plus 4 lambda plus 16. So, and we also wanted to take out, let's see, what was it? Lambda minus 2. Now, there's a way of writing lambda minus 2 with dots, where you use constants and then lambdas. And what you do is you put a solid dot for a positive number and a circly dot, an undot, and anti-dot for the negatives. And of course, I'm also, well, not of course, but I might also need this, which would look like this, because we'd have a minus here and a plus here. So what I want to do is I want to take these guys out of this. And I'm going to make a big thing for this so we have lots of room to work. 4 boxes. This is for the constants, the lambda squareds, and the lambda cubes. And for example, since I have 4 here, I could do -4 as dot, 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 and then I'll do a dot here, and then I have a plus 4, so I'll do a dot, 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 dot. You might be asking, why am I not writing it in the middle? And actually, I mean, maybe I should be. I don't know, I'm going to be doing some circling, so I don't know the best place to put the dots at this moment. But basically what I want to do is I want to look for patterns like the 2 patterns I have shown here and here in this. Okay? Let's see. Starting here, I want to find a pattern. I don't have any dark dots here. I do have a light dot, but I don't have 2 dark dots here. So what I could do is I could make them. You might say, I can't make them because that would change the problem. You'd be correct. But you can always add 0. So I added 2 dark dots and 2 light dots. I haven't changed anything. And then boom, I have one of these boxes. Now, of course, it's the negative version. So what does this give me? It gives me a negative where this domino leaves off. So that would be give me a -1 here. Okay, so I'm not going to get any positives here because there's no more dark dots. And what I could do is I could say, okay, I could do this, and I could do this, but I need some more dark. I need some more dark dots here. Otherwise, I'm not going to be able to finish this. So how many do I need? Well, apparently I need 8 dark dots. So I'll make 8. And I get these, but I can't just make 8 dark dots. I have to make some light dots too. And now I really wish I hadn't done that. But I'll make my 8 light dots. Okay? And now finally, I could take this light dot with, say, these 2 here. That's like a domino. This. So how many times am I going to do this? Well, I have the exact number of dots I need to finish this. That's because this goes in evenly. So how many of these types of things am I going to have after circling? I know it would be very messy for me to continue the circling all the way because of the way I poorly placed my dots. If I had just put this a little to the left, it would have been beautiful. You can do that when you recreate this in your notes. Okay, how many do I have? Well, I have 8, and they're all this variety, so that's going to be negative. And here I have 1, 2, 3, 6. Okay. And of course, this was for the lambda squareds, this was for the lambdas, and this was just a constant. And what do I have? I have minus lambda squared minus 6 lambda minus 8. And if we look, that's the exact same thing that we got over here. So it's another way of doing your polynomial division. You can do it all with dots. Now, it's not the best with a number like 16. It's really sweet and quick if you have like lots of things with like 2 or 3 dots. That comes out beautifully, like in each of the sections. You can do visually, you can do your long polynomial division very nicely in that fashion. But I just wanted to show you an alternate way to divide. Of course, we could have divided by one of the other dominoes. What are the other ones we would have had? Well, we would have had lambda plus 2, which would look like this. And I think we would have had a lambda plus 4. For our lambda plus 4. And we could have taken these out as well. As a matter of fact, we have a little bit of time. Maybe let's try to figure out what would happen if I did the lambda plus 4. So one more time, I get this, this, and this. I don't know, drawing 16 dots does take a bit of time, but let's see if we have time to finish this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and I have 4 of these dark dots here, and then I have 4 light dots, and then I have 1 light dot here, and let's take out this. This is going to be a much better one than we did lambda plus 4. And remember that minus lambda minus 4, the negative, if we take out a negative, it's going to look like this. Okay, so what can we do? Well, I see some lambdas plus 4, and I see a minus lambda minus 4 right here. I could do this, and then this, so where do these dominoes end? Well, this was a negative 1, so I get a negative 1 here. These end here, so I get a positive 4. And what would I have here? Well, I would have, this was the lambda squared column, so I get minus 1 lambda squared plus 4. So that was a nice quick one. I didn't choose the easiest thing for me to pull out. As a matter of fact, I chose by far the hardest of the 3, because if I were to pull out the one dark here with 2 darks here, at least I would have gotten rid of things. The sort of one we chose to divide by ended up being the messiest of all of the options. And of course, if you have this, it's very easy to get the other roots too, because hopefully you have a formula for a difference of squares, 4 minus lambda squared, and then you get your 2 plus lambda and your 2 minus lambda to get your other roots. So I wanted to give you guys this as an option. This is the dots method, the exploding. And if you do a search for exploding dots, James Tanton, you will find some great stuff. It is incredible how many different things that you can do just with this method. But okay, that's a lot for one problem, but we've been doing things in many different ways, right? So that's what happens when you try to see how many different ways you can do things. So that's an example of diagonalizing a 3x3 matrix. Not super quick, even if we were to just do the bare bones. Certainly not as quick as a 2x2 matrix. But I wanted you guys to see one of those done from beginning to end, because it might have been a while since you guys saw that. Bye-bye.